Okay, here's another nice little old amp, another Watkins amp to have a look at. This is actually an old Watkins Scout, which must be one of the very early amps that Charlie Watkins made. This one's particularly interesting. It's the black and cream one with the brass grill and the little brass type Watkins name, which he used for many years on all his amps. This is obviously a single speaker one, and if we have a look at it, this one particularly interesting. So when we turn it round, we discover it's got a speaker on the back which someone has put on to give you a speaker on each side. This is another very early grill, the red sort of little polka dot or little dot cloth. And here's the control panel. So you've got Watkins Scout, and this one is got the tremolo, which he had on a number of his early amps. So it's probably got a similar type of circuit, but the actual layout was different from what he used on most of his amps following. Although it's got a folded chassis, all his following amps tended to have the sockets on the front, and this one's got the inputs on the back here, and a little voltage selector, a giant bulb, a couple of knobs of original knobs here, but we lost some. They've been replaced by some a long time ago by some sort of aluminium ones. The foot switch here, unusual. On later amps, all his foot switches for the tremolo were wired in solid, and it used to come out through the bottom. So we've still got a hole here. Came out the bottom for the foot switch was wired permanently, but this one plugged in through old-fashioned connector, and this is foot switch is obviously missing. And that would just be a short or non-short, no doubt. Two inputs, one is called a microphone, so that's probably hopefully more sensitive than the other input, but we'll find out when we take it apart and have a look. And this one, it's not really clear from where all these white lines go, which does what. I'm assuming that this will be the volume, tone, speed and depth probably from these. The arrow goes over to here, and we'll have a tone and volume off of this. Got the switch, typical. They're on the volume on this one. Normally later on, Charlie always put the switch on the tone control. So still got the original handle which he used on amps for ages, and the actual construction with the little pipe in and the two-tone cabinet looks pretty standard. Obviously not the original. This black, this red on the back was, not sure what amp that's from. Cutouts and things here. So I'll be taking it apart and having a look inside, and I'll edit it all together. Okay, look inside the Scout. I've taken the back panel off, and you see the back panel is from a much earlier amp, being fitted on the back as a back panel next to the speaker. This obviously originally had a 10-inch speaker on it, but it's now got a little 8-inch being screwed on. There's an ELAC, a little bit of cone damage down there, but nice thin paper cone. And this speaker in here is not an ELAC. I don't know what make of speaker this is actually. Someone will know. Looks like a ceramic magnet. Anyway, it's a 10-inch, and these two speakers have been wired in series. I don't know if the tapping on the transformer's been changed, but I mean series can work. even though the amps aren't designed for it, you can put speakers in series better than putting them in parallel where you can draw a bit heavy current. Anyway, looking inside, this amp apparently, according to the internet, was made between 1963 and 65, the Scout. And inside we've got a circuit board construction, so it must be one of the earliest circuit board construction amps, and it's pretty crude, almost like a homemade affair, where the components are laid out on an old sort of Paxoline type of board, and then they've just been crudely wired to where they're going to go, the circuits, and joined up all over the place, and then it would be etched out. Nothing. It's like hand wiring something, but instead of using wire, they just use a circuit. There's been a bit of repair down here. The track has been repaired by a couple of wires, and this resistor down here, the insulation on the wire is all sort of shriveled, so I don't know whether it didn't have any insulation or whether there's been some weird sort of short circuit, because insulation on the other components, like this one down here, the yellow, which that probably was, isn't shriveled. Anyway, most of the components on this board look original. You've got things like these little bypass capacitors there before the ECC83 valves. Giant Hunts capacitor will be like off one of the anodes, no doubt. All these are carbon composition resistors. This smoothing capacitor here is roughly put on the circuit board. It's probably original. These two capacitors here, 200 microfarads, 18 volts, they'll be off the EL84s. Normally the EL84s would be in push, probably use one capacitor and one set of resistors, but on the cathodes, but in this amp they've got them individually, which is good, extra cost. And giant resistors on the cathodes, looks like a 120 and a 120, so 240 ohms, it's about right, 220 ohms I've seen on other Watkins amps. All these old RS components is what a lot of manufacturers used in those days. RS radio spares was a great source of components, and especially transformers and things. Easy, one of the first component suppliers that supplied spares to everyone in those days. Still going today, huge company. And you've got all the potentiometers off the controls. They look like they could be original. And switches on the volume control on here, the original giant bulb. Transformer, see that yellow stripe around the transformer, that's the radio spares. They used yellow stripes on, that was yellow, there was their colour. And the output transformer under here, also with yellow stripes, that looks like an original radio spares. The valves, well, the preamps, ECC83 I'm sure, these two with cans on. This is an ECC83 tungsten, nice old valve, it's got a clip. There was a space there for another valve, obviously not used on this circuit. Then the two EL84s, push-pull. This one's failed, as you can see. It's got a white end, which means it's let air in. I don't know where that would have happened. Maybe it's just failed. I've got a leakage in the base somewhere. When these getters are flashed and they manufacture them, you get this nice black silvered effect here, which is just combines with any gases left in the tube when they're manufacturing it before they seal it up, and it also collects any additional little bits of air or anything that gets out of these things when they're heated up, so it keeps a nice vacuum, but when air gets in it turns totally white. So this one's failed. Further down, socket for here, probably for an EZ81 rectifier valve. This one's been modified, so the EZ81's now gone, and it's a straightforward mod that you can do on amps. Replace them by two diodes. These have been soldered to the back of the valve base. You can even plug them into the valve base if you know what you're doing. These are 1N400 something, pretty high power diodes. You could use smaller ones, the current isn't that high. We'll put the voltage up a little bit, not too much, but a little bit, and nothing, or none of the circuit be running at the limit of voltage, so a little bit of voltage will give you a little more power, no doubt. This can easily be reversed. These can be taken off and the valve be put back in, which I might do. And a few mods done. Next to the smoothing capacitor put in here, probably to try and reduce a little bit of hum. Push-pull amps are not too bad on hum, as the push-pull normally rectifies out the hum, but it's there anyway. A couple of fuses fitted inside. Typical gold folded chassis like Watkins used on all their amps. This one goes all the way round, obviously, and then the back fold into the back panel for the sockets. Later, nearly all later Watkins amps, these sockets were put on top, and this part wasn't on the back. Still gold colour, used like a hammerite finish used on all these chassis, all the ones I've ever seen anyway. But the circuit board, very unusual to see a circuit board on such an early amp. Amps that followed this went back to the point-to-point wiring without circuit board, which looks, well, it looks nicer. I don't know whether it's quicker. I mean, this is supposed to be quicker to manufacture because these can all be soldered on and put in. Bit difficult to service though, because once this is screwed in, then all the wires are soldered to the board and additional resistors soldered across, which means you can't really take the board out, which makes it quite difficult to service if anything goes wrong with it. You'd have to cut any component out and try and solder onto the solder positions. Just looking at the valves here, there's another little circuit board here that takes the two ECC83s, and not sure why they've done that. Oh, I see, it's unlike rubber mounts, so to reduce vibrations, microphonics. Quite a good idea if it works. I don't know where the rubbers have gone. Twisted wires for the heaters, and it gets pretty thin going down to these. I don't know why these are such a thin wire. And a little bit of screening on the wires going to these high sensitivity areas here. A little bit of screen wiring. It doesn't really make a difference in my opinion, but it can help reduce any pickup capacitance. Well, it adds a little bit of capacitance actually. This rusty screw holds down a tag which has been used as an earth point at the front end, which is good. Lots of rusty screws in here. Amp's a bit dirty, but I'm sure it'll work. I mean, there's corrosion and dirt. As I said, there's been a repair done down there. Don't know why that would have failed. That'd be pretty unusual to fail unless something shorted along there. Tremolo part circuit here. Looks like the circuit's going to be very similar to most of Charlie's push-pull EL84s. Originally they were called 10 watts. Then later on it became 14 watts. Then it became 17 watts, but the circuit basically remained the same. But I mean, 10 watts probably because there was the Vox AC10 originally, and then probably there was 14 watts when there was the Vox AC15, and maybe he thought, oh no, 15, I'll go higher, AC17. So 17 watts is more than the Vox's 15 watts. So but I'll be drawing out circuit, checking these components. I'm not going to replace all these components on the mat, of course. I obviously check all these electrolytics. Although they're discoloured, I mean, I can test the capacitance and the resistance with my meter, and then I'll, if they all look alright and everything, I've got to obviously replace this valve. I test the other valves, and then I put it on the variac and bring the voltage up slowly, which I can do on my variac, and also monitor the current as I bring it up, because the current will, the AC input current, if there's a fault that you don't spot and the current is high, starts going high, you know that somebody's drawing a lot of current, which could be a short on the power supply that you don't notice at first. And then as you bring the voltage up, I'll monitor a couple of voltage points, normally the main power rectified power line, and perhaps on the valve, on the resistor, see what current they're drawing, and just watch the capacitor and also listen for any crackling noises, any puffs of smoke or anything weird on these really old amps. And you bring up the voltage slowly, checking everything out, and eventually you can get to max, and then and you can also hear anything through the speaker if anything's crackling, popping, or making a weird noise. And that way you can get them working. I don't see the point changing every component in these old amps. I mean, noise, hum, noisy pots and that. I mean, that's the charm. If you want an amp that has none of those things, you buy a new one, which probably won't sound the same, but won't have any noise. But you wouldn't be giving an amp like this anyway. So we'll see what happens. I'll be checking it out and putting more on the video. Okay, this is the Watkins Scout. I've turned the chassis, taken the chassis out, it's held in by 2 screws each side, just through the wood. So I've taken them out, turned it over, just to see what's on the other side. You can see here's a nice old mains transformer, probably RS components. It's got this yellow band round it, which was on all the RS components. Transformer yellow was their colour, and the same with the output transformer, yellow band, and you've got the smoothing capacitor. Now the output transformer is a reasonable size, but as on all Watkins transformers that I've seen, he did use the snubber network, which is put on the primary side of the transformer. Most manufacturers didn't bother with those snubbers, but the reason that they're on there is normally if you use a very small transformer and drive it really hard, it prevents high frequency ringing and breakdown of the insulation, which can destroy the transformer. It doesn't affect the sound in any way, but it does stop the very high frequency transients. Also, if you disconnected the speaker, it protects the transformer, but if it's a combo, this the speaker's going to blow open circuit. It's pretty unlikely. And on this decent sized transformer, I can't see why you would actually need those snubbers. But anyways, put them in, resistor capacitor on each side of the primary, and there's also a 10k resistor just there, which must be a feedback on the circuit, which I'll find out where that goes. It's got a little grey wire, disappears inside. But the main interesting thing on this side is this capacitor. It's a Plessey, and it's the original, and it's got the date code on it, and gives an idea when it's made. Just here it says that must be January, Jan 64. So we know that this was made after 1964 and probably during 1964. So that's interesting. So it confirms the date when it was made. Anyway, typical gold folding metal chassis. Everything's original on this side, and I'll turn it over and continue with the other side. Valves, by the way, the 2 preamp ones here are very nice little mallards. It would be original. The tungsten one here probably could be original. I don't know whether they use the tungsten just from stock or whether it was changed. The EL84s probably not original. I mean, EL84s don't last very long if they're used a lot. This is a mallard design. I can't. The etching's rubbed off, and this one that failed was, as you can see, was the was a different type of valve. No, it's the same. No, they're not mallards. So because you can tell by the getter design on top. Anyway, I'll be testing them, testing the valves. I doubt if there's anything wrong with the ECC83s. They always seem to keep everything, keep their spec pretty well. And I'll put in a nice pair of EL84s, and then I'll continue with the testing and drawing out the circuit diagram. Okay, here's the Watkins Scout. I've checked the valves and got 2 EL84s for similar specification I plugged in. The 3 ECC83s tested absolutely perfect. 2 mallards and a tungsten, so I put them back in. I've left the modification of the diodes in place of the EZ81. I've taken out the extra smoothing capacitor that was in there and left the original. I've checked everything else out and haven't replaced any components at the moment. I'm just going to show you what happens. I've put a number of meters on. I've got one on the HT, the highest voltage rectified off the transformer. I've got one on each of the EL84s to check the current through the EL84s. And I've got one on the phase splitter on the cathode. And this is the variac. So I've set it to 0. I turn it on, and then I start advancing the voltage. It comes in, it starts about 40, and this is the very important ammeter. If there's a fault on the transformer, any power supply section, the current will go up pretty high. So you'd expect it to be on this amp well below half an amp. You can also listen to the speakers connected. We just put it up a little bit because not much will happen as you advance the voltage at first. The AC input about 100 volts. Over here you see that the DC is already 162 volts. Be no conduction yet on any of the valves because the heaters are still low. And the current is extremely low. I'll just put it up a little bit more. Say just 140, 150, and just see the 250 volts on the power supply. And now there's a little bit of current starting to flow in the 2 EL84s. And I can hear a bit of noise from the speakers already. I'll advance the up a little bit more, 240, 250, and you've got current flowing in the TL84s, not quite equal at the moment. And down here you've got some voltage on the phase splitter, about 50 volts on the cathode, which is about right. Current still really low, about less than 0.2 of an amp. Take the voltage up a bit more. Just listen to that speaker, no exceptional noise, a bit hiss, tiny little bit hum, so it means there's no problem in here. No crackling or smoke, no unusual sounds from the speaker. We've got 300 volts now on the HT, that would be to the primary on the output transformer. and about the same on the valves. The valves are fairly well matched at the moment, about just over 8 volts, and that's a cost of about 240 ohms. I did check those resistors and they're not quite in spec now. One pair is slightly different value to the other, but I didn't bother changing them. They're down there, the big resistors and the capacitor. On this amp they've got one set on each valve. Normally you would only have one for both valves. Anyway, 223, which is almost the max. On the Variac scale here, it's reasonably accurate. It says about 220. I'll just push it up to say 235, which is the recommended voltage. Often the volts on the mains around here is about 240, so I set it about 235. Check the current. That's pretty what I expected to be, about just under 0.25. 236 it's showing on there. Okay, the HT 320 volts and 9 volts approximately across those resistors. So on the circuit diagram I've got here, if you look at here, you've got the I'm measuring 9 volts across these resistors in series as 240. So using the calculator you can work out the current draw. It's what I said, it was 9 volts. Just turn the calculator on. 9 divided by 240. It's about 37 milliamps at the moment. So normally I expect these would run near 50 milliamps. So it's quite low. I can check the circuit again later. 320 volts. They're stabilised about 9.2, 9.4, and we've got 60 volts on the circuit down here to show you. On the phase splitter here, got 60 volts here. Now that got a voltage divider here, 100k, 33k, and that is giving you the bias to these valves through these two 1 mega ohm resistors to the grids there. So which then is set this point at 60 volts, which means that you can get a maximum swing across the outputs to feed the valves. And as I said, we're getting 300, actually it's about 319, 320 volts off of here. Now the EZ81's been replaced by 2 diodes, so if we were using the EZ81 it would probably be slightly less voltage. These are still the original smoothing capacitors, 50 microfarads. And there's one other smoothing capacitor just here, 16 microfarads. And normally you would split these ones with another capacitor, but everything is running just off that 16 microfarad capacitor, all these 3 valves here. If you're not careful you can get a little bit of noise feedback, especially when the tremolo is on, but we'll see what happens. So bit of noise from the speaker, bit hissy. Valves are stabilised, 60 volts still. This one's just timed out, it's been on too long. See if I can get it on again. 9 volts on one, 9.4 and 9.3 on the other. Still 319 volts, and the current is dead stable, 236. I'll check a few of the other voltages and write them down on the circuit board. Now I'll plug the guitar in and see what it sounds like. I've only got the one speaker connected up now. This is a 16 ohm speaker, and it was a 16 ohm tap on the transformer underneath. The other speaker that was connected up when I took this apart was a 4 ohm in series, so making like a 20 ohm speaker on a 16 ohm tap, which would have worked, and I'll probably connect it back up and see what it sounds like. So that's seems to be working okay at the moment. I can check the voltages on the on these capacitors down here, just to see what the base is, and I put it on this meter there. You got a 1.78 volts on that ECC 83 cathode, and this one only 0.8, but it's slightly different bias, I think, so I'll have a look at that. So 0.8, 1.78, excuse me, and there you're on the circuit diagram. Just measured the voltage on that one and the voltage on that one. This one looks like it's probably the 0.8, or maybe that one, because it's only got a small resistor on the top, 56k. Anyway, I'll do some more tests and write it all down, and probably add a little bit of note on the circuit voltages later. So everything seems to be stable. So this goes to show with all the original old components when it was built in this amp, and I mean, I haven't bothered to change any of them, and it's working. So people who say you've got to change all these components every few years, 5 or 10 years, well, that's maybe if you're gigging and using the amp every night, yeah, but on these old amps I don't want to mess it up because it's a bit of history. Okay, I'll add some more later. Okay, it's just a quick check with the guitar before I screw it back together again, just to check out the functions. There's no foot switch, but by using a little shorting plug on here, I've switched the tremolo on. I've plugged into the tremolo socket here. So that's full depth. I turn the speed up a bit. Not a lot of depth, but speed down. So it doesn't really go that slow either. Volume and tone control on this input. Let's put it down. Turn the tone up. I'll turn to a brighter pickup. And the volume, it's on max now. Very nice and punchy sound indeed. That's in the tremolo socket. Now on the other socket here, that's volume. seem a bit wobbly, but it's still working. Tone. Turn the vol down a bit. Now I have done a small mod on here where I combine the two inputs on the valve together, so you've got both the ECC 83s working together, so when you plug it in this one you'll notice an increase in volume and general boost the tone all around. Pretty distorted. I'll turn the volume down a bit. That's a tone. Very trebly. Bass. Just a single ECC 83 grid. So I'll put it back together. Everything seems to be working. The tremolo is a bit weak, but maybe it was weak when it was designed. But besides that, everything seems to be fine. So I'll screw it back together and just do a test. Okay, I've put the amp together, just going to test it at some vol. I've plugged the Stratocaster type guitar directly in. I've got it on the treble pickup. I'm going to put it into the tremolo input at the moment. I better turn the tremolo up a bit. So, check. The tremolo doesn't have a lot of depth, there's a lot of speed. I'll turn it down. Not a lot of depth. Good tone though, so I'll disconnect the tremolo by taking out the shorting plug. See this. A bit more volume. A lot of punch on that. Oops. Try it on the other input. This is the single input one. When your volume. Try. I'll try it on the boosted input. I did just turn the bar down a bit. Treble pickup again. Treble and punch on that. I'll try the bass pickup on the guitar. Maybe not all the bass. Pretty lively, really good sound, punchy as hell. Bit of hum pickup on the guitar. So, except for the tremolo's a bit weak, the sound is absolutely incredible, really punchy, brings out all the tones on the guitar. And switch at the treble pickup. Sounds pretty punchy to me. Turn the volume down on the guitar a bit. Try a bass pickup. Nice sound. Pretty nice punchy amp, really good sound with the Strat. Tremolo a bit weak, but really old amp, turned out pretty good. There you go. Whoops. Turn it off here. Silent.